This talk was presented at Google I/O Extended Grand Rapids in 2023.
It's a B2B alcohol marketplace for businesses. They basically simplify the alcohol purchasing process for retailers by aggregating the selling and the distribution process. Besides my day job, I'm the founder of the Spelt Sirens. It's a group for women and non-binary people in the Spelt community, and I co-host 2 podcasts. Alex just talked about one with my wonderful co-host, Alex Patterson, and I also do Spelt Radio. Enough about my stuff, though. Before I dive in, I want to say thank you to Alex and Kyle for organizing this and the amazing GDG events I've been coming to. And thank you for having me as a speaker. I can only hope that I do half as well as the speakers before me, because I'm going to be looking at and potentially reading from my notes a lot. So about halfway in, I'm going to lean on my Spelt friends that were asking about it earlier to cheer me on, because I'm going to be talking about Spelt a little bit later.
So the earrings.
Yeah, so I have Spelt earrings on and the Spelt Origins shirt on as well. So with that, welcome to Design Systems, baking consistency into your workflow. See if I can figure out how to make the slides go. There we go. All right. At Provi, I am building out the Fizz design system. Currently, I'm a team of 1, and my only focus is on the design system itself. We do have an amazing team of designers behind that work to help keep the UI kit up to date. And I want to give a shout out to one of the lead designers, Sonali Agarwal, for all of her design system passion that drives me to want to do more, and for helping to come up with some of the amazing designs and content in this presentation. First, we'll talk about the recipe, the steps to make a successful design system. Next is the ingredients, all of the pieces and tools we need. And third is baking the cake, putting all of the ingredients together into something that's consumable. Then we can taste the cake and test the work that we have put in. And finally, we'll discuss selling the system, packaging and publishing to consumers. Creating a design system is like baking a cake. It requires careful planning, attention to detail, and a recipe for success. Just as a cake recipe requires specific ingredients in specific quantities to ensure the cake turns out delicious, a design system has specific guidelines, assets, and components that keep the visual and functional aspects of a product or brand consistent. The definition of a design system is the source of truth that allows an individual or team to design and develop a product easier and faster while maintaining consistency. Think of a cake recipe as the core of a design system, the source of truth. The recipe specifies the ingredients needed, the measurements, and the steps to follow to achieve a successful outcome. Similarly, the design system defines the colors, typography, layouts, and components needed to create consistent and cohesive designs across a product or a brand. Like a baker may experiment with variations on a recipe, designers can modify or iterate on a design system to fit new features. But just like having a list of ingredients doesn't necessarily mean you'll end up with a delicious cake, changing a recipe can lead to a less than perfect cake, and inconsistent use of design elements can lead to a confusing or disjointed user experience. Things become inefficient. They start to fall apart. Both baking a cake and implementing a design system require careful planning, attention to detail, and consistency to create a final product that is both visually appealing and functional. Atomic design is a methodology used to create a consistent, reusable design system. Just like a cake recipe, it involves breaking down the design into smaller, more manageable parts that can be combined to create a cohesive whole. Atoms are the smallest and most basic building blocks, like flour, sugar, and eggs in a cake. They are the individual elements that make up the design, such as buttons, labels, and icons. Molecules are combinations of atoms. Similar to how eggs and sugar combine to create the batter, molecules are more complex than atoms, but still small and reusable. They can include things like form fields, search bars, and navigation menus. Organisms are combinations of molecules and atoms that make up more complex and functional parts of a design, like cake layers. Organisms can be headers, footers, product listings, and more. Next, there are templates that place these organisms or components into layout forms like cakes in a pan. And the final piece are pages, where the entire UI comes together to look like the fully baked cake ready to eat. So just like how a cake can be made up of various combinations of flour, sugar, eggs, and other ingredients, a design system created using atomic design can be made up of various combinations of atoms, molecules, and organisms. By breaking down the design into these smaller parts and reusing them, atomic design allows for greater consistency and efficiency in design. A design system consists of several key ingredients that make the final product consistent and comprehensive. Design tokens, the style guide, design assets, a component library, and documentation are all layers in the design system cake. Design tokens are a way to define and manage visual styles, such as colors, typography, spacing, and more. In a design system, they're essentially a set of variables that represent these visual styles, allowing designers and developers to create consistent and cohesive designs across different platforms and devices. By using design tokens, it creates a more consistent and efficient workflow. Teams can create a centralized and standardized way to manage the visual styles of a design system, making it easier to maintain and update the system over time. They also provide a more efficient workflow for designers and developers, as they can quickly and easily apply the same styles across different components and pages of a design system. Design tokens can be implemented in a variety of ways, such as using CSS variables or with JSON files or other programming languages. Those would need to be transformed before they can be used by the developers on the end. Using tools like Style Dictionary, you can take the token file and turn it into something that's usable in your system. They can also be integrated with other design tools and systems so that designers and developers are using the same language when creating interfaces. This creates a comprehensive and streamlined workflow. Sometimes it's easier at the beginning to start by manually updating a small token file and keeping it up to date with the designer's UIKit tokens. However, as the design system scales and grows, it can get out of control quickly. This is a good time to start bringing in a more automated approach, like plugins and things from Figma. At Provi, we use Sass for our style language. Design tokens may contain base tokens similar to atoms in the atomic design, and then have more contextual tokens that call on that base layer. The design tokens are a crucial aspect of any design system, providing a standardized way to define and manage the design properties, such as the colors, typography, and spacing. You take those base design tokens and then create a contextual token that will call upon that base layer and keep it consistent and make it a change only in one place. So by using a centralized set of design tokens, teams can ensure consistency in their design language across the different applications and platforms. A style guide is a document that outlines the visual and design guidelines for a brand or product, including its color palette, typography, imagery, and other design elements. It serves as a comprehensive reference for designers and developers to ensure consistency in the design and user experience across different platforms and devices. The method and technique for preparing and baking the cake. In a design system, a style guide is an essential component that provides a centralized and standardized way to manage the visual styles of a product. It establishes the rules and the guidelines for how the design system should be used, ensuring that all components on the page are designed and implemented consistently. A style guide typically includes information such as the brand's color palette, typography guidelines, iconography, grid systems, and user interface patterns. It may also include guidelines for voice and tone, accessibility, or responsive design. A comprehensive and consistent style guide reference helps to streamline the design and development process, reducing the risk of errors and inconsistencies. In addition to serving as a reference for designers and developers, a style guide can also help to communicate the brand's values and personality to stakeholders, such as marketing teams and business executives. It can serve as a visual representation of the brand's identity, helping to ensure that it is communicated consistently and effectively across all the touch points. Design assets, sometimes called a UI kit, typically include visual elements such as the icons, images, illustrations, and animations. They may also include design patterns, templates, and user interface components. These assets serve as the building blocks for designers to create the consistent and cohesive designs and for the developers to implement them. In the same way that ingredients in a cake recipe need to be measured and prepared in a specific way to achieve the desired result, design assets need to be standardized and organized to ensure consistency and efficiency in the design process. This is where the use of design tokens can be helpful, as they provide a standardized way to define and organize design elements. Design assets in a design system should also be easily accessible and shareable among team members to ensure that everyone is working with the same assets all at the same time. This can be achieved through the use of a centralized asset library or design system tool that allows members to easily access and use design assets. Figma is a common tool with designers now that they're using to create components and then share with all of the teams that they work with. Flexibility is also an important consideration. While consistency is important for creating a cohesive and recognizable brand identity, it's also important to allow for some flexibility to accommodate the needs of different platforms, devices, and user needs. If you don't allow for flexibility in your design system, you end up with a designer detaching a component and they will do with it what they will, and then you'll end up with hundreds of variations across your product and you lose the consistency and the efficiency. This would be like customizing the cake recipe to accommodate for different dietary restrictions, preferences, or occasions. For example, you might offer variations of the same cake recipe that are gluten-free or vegan, a range of colors or flavors, a number of layers. This allows you to cater to a wider range of customers and needs while still maintaining the overall integrity of the cake. Similarly, in a design system, providing some flexibility in design assets can help to accommodate different user needs, contexts, and platforms. This might include offering variations of the same UI component for different screen sizes or devices, or providing different color palettes or themes to accommodate different brands under the same umbrella or user preferences. However, it's important to balance this flexibility with the need for consistency and maintainability in the design system. Too much flexibility can lead to inconsistencies and a loss of brand identity, while too little flexibility can limit creativity and innovation. A well-designed design system should strike a balance between consistency and flexibility, providing a framework for designers and developers to work within while still allowing for some customization and flexibility. Overall, design assets are an essential component of a design system, providing the building blocks for consistent and cohesive designs. By standardizing and organizing these assets, designers and developers can work more efficiently and effectively, resulting in a better experience for the end users. The component library includes the reusable UI components, such as buttons, cards, and icons, like we talked about in Atomic Design, that are used across a company's digital products. But this is coming out of design and going into the code and actually creating the code for the components that are going to be used by your end system. Typically, they're written in a coding language that the majority of the company is using for their front-end applications. Other larger companies and design systems may include components in multiple languages or use platform-agnostic approaches. At Purview, we use a combination of these. We package a style library with all of the CSS for everything in the design system. I already mentioned that we use Sass for that style library, and this covered the needs for the company when it was small. But as more developer teams started to use it, the utility classes were not used consistently across the application. They saw a need to expand on the style library with a Svelte component library, which is the framework that they chose to use, to allow a more plug-and-play experience for the developers while still utilizing the existing style library. They brought me on to help with this and start expanding and scaling the design system. Documentation is the last critical aspect of a successful design system. It helps to ensure that designers and developers have a clear understanding of how to use the different components, styles, and assets in the system. Just as the recipe provides step-by-step instructions for baking the cake, the documentation provides clear guidance on how to create and use pieces of the design system. It combines all of the ingredients in the right proportions in order to create the perfect batter. Good documentation for a design system should include references for both designers and developers to ensure that everyone using the system has access to necessary information. It should start with a high-level overview of the design system, including its purpose, goals, and design principles. In addition, step-by-step tutorials and demos and how to use the different pieces should also be provided. Design assets for the UI kit and the style guide provide designers with everything they need to start creating new interfaces. A clear explanation of the different styles, followed by a comprehensive list of all the components in the design system, along with clear descriptions of their purpose, usage, and variations, ensure the designers and the developers know the proper usage of the system. Code snippets and examples of how to use the components and styles in different contexts, such as in web or mobile applications, make it easier for the developers to implement them and easy to copy and put into your code. Finally, it's important to note that there is always room for improvement and ways to increase the experience of using the design system. By adding more to the documentation, having clear and comprehensive documentation for a design system can help to ensure that it is used consistently and effectively across different teams and projects, especially as your company starts to scale and grow. It can also make it easier to onboard new team members and provide a valuable resource for ongoing design and development work. Brad Frost, the writer of Atomic Design, said that a design system is a multifaceted layer cake. To create a cohesive cake, each layer of the design system must be able to stand alone as a fully functional piece. This ensures that the system is modular, scalable, and easy to update. Each tier is an individual piece of the design system that is built and maintained separately, but comes together to create that cohesive whole. To do this, I made the decision to move our existing packages and separate repos all into one monorepo to more easily manage and maintain consistency in the design system as a whole. Using a monorepo workflow enables collaborators to work on different parts of the system simultaneously and ensures consistency and efficiency throughout the entire system. By adopting a monorepo workflow, teams can bake in consistency from the start and deliver a well-structured design system that is easy to maintain and update in the future. A monorepo workflow provides a centralized code base where all of the code related to the system is located in a single repository, making it easier to manage, maintain, and update. It allows for code reusability across multiple projects, which is especially useful for shared components or styles. It promotes better collaboration among team members, leading to increased productivity and faster development times. And finally, it streamlines the workflow by eliminating the need to switch between different repositories and contexts and simplifying dependency and versioning management into one branch. With all the code in a single repository, it's easier to track changes, identify issues, and roll back changes if necessary. And yes, I'm making PRs to the monorepo. When it comes to building a monorepo, there are several tools out there. One popular tool is PNPM, which is a fast and space-efficient package manager that allows you to share dependencies across projects in your monorepo with workspaces. PNPM uses a technique called shrink wrapping to manage dependencies, which means that each package only needs to be installed only needs to be installed for the specific version of a dependency once for your entire computer. So no matter what directory it's in, it gets installed one time and that's it. This results in faster installation times and reduced disk usage. Another tool I use is called NX, which is a toolkit for building enterprise scale applications and provides a number of helpful features specifically for working with monorepos. NX allows you to define and manage your monorepo as a set of projects, each with its own dependencies, configuration, and build processes. This makes it easier to manage those multiple projects, even from a single repository. And you still share code and resources across all of those projects. To use PNPM first, make sure you have PNPM installed on your machine. You can install it globally using npm by running the command npm install -g PNPM. And once you run that, you never need to run npm anything ever again. Just, if you don't like the extra letter, you can set up an alias for it. To create a new monorepo, navigate to the directory where you want to create your monorepo and run the command pnpm create and the name of the monorepo. This will create a new monorepo with the specified name, and you can manage your packages in your monorepo using the command pnpm command. Next, you can add packages to your monorepo using the command pnpm add package name and -- workspace. This will add the package to the monorepo and create a workspace for it. Or you can just edit the workspace file directly in the pnpm workspace.yaml file by declaring the packages and then the name of each directory that you want to set up. To use NX, you can install it using the command pnpm-add-d for development and then @snarwhal/CLI. Once installed, you can use NX commands like nxgenerate and nxtest to manage your monorepo. And the NX graph command, which I really like, allows you to view a nice graph of all of your packages and how they connect to each other in their dashboard. The next step is to start figuring out what you want to include in the monorepo for the design system. You can use any pattern or naming that you like, but I use sites and packages. Sites are the actual applications and websites. These can include the design system documentation site, and sometimes even sites that will implement the design system, like the main apps, can live in the sites repo, in the same monorepo. The packages directory contains all of the reusable code that make up the design system. The packages can include the components, the styles, icons, tokens, and any other packages that you're publishing. At Provi, we use a combination of tools in our design system. When I started, the entirety of the design system was built into one Eleventy site with the style library and the documentation all under one repo, and there was a separate icon library that was another Eleventy repository. After combining these into the monorepo, I was able to point Netlify to the correct base directories and build each site on its own domain without changing any of the underlying build steps. I just pointed each of the sites on Netlify to the correct base directory, and it navigated and set up PnPM workflow and built each site independently. Probably could have used NX to do that as well. The new component library was built using SvelteKit. All my Svelte friends back there. I had a lot of assumed knowledge coming into this that everyone knows what Svelte is, so I didn't include anything in the talk, but I just wanted to talk a second about what Svelte is. It was kind of a paradigm shift when it came out. It's akin to React and Vue. It's a front-end framework, but it is a compiler. So it kind of like shifts the paradigm to the build step. You have the compile step, and then you're going to ship less JavaScript to the end user because of that. And then SvelteKit is the meta framework around SvelteKit that gives you the routing and the rendering options that you want when you're looking for a meta framework, similar to Next and Nuxt in the presentation earlier. So SvelteKit is going to give you the routing API that you need. It's going to give you, you can do server-side rendering, client-side rendering, you can do static pre-rendering, any of those things, and even like a mixture depending on what route you're on. And I just wanted to touch on that a little bit before we actually dive into this part about installing. So this is the Svelte CLI, but it is a way to generate a SvelteKit application. So you can create a new SvelteKit application by running the pnpm create svelte command, and it kicks off a fully featured CLI, or command line interface, that helps bootstrap several types of SvelteKit projects and integrations. You tell it where to create the project at, and you can choose a library project right from the templates there. They give you a demo app, a skeleton project, or a library project, which is a bare bones scaffolding for your new Svelte library. And you get started creating a library right off the bat. The component creation process for a component library involves several steps to ensure that each component is well designed and meets the needs of the end users. The features, the API, the function, and implementation are all important pieces of the puzzle. It really forces you to flip your thinking from how the component is used to allow it to be as dynamic as possible. You have to think about how the developers are going to use it on their end, not how you're actually creating the component. Before creating a component, you need to define its purpose and the features that it should have. This includes understanding the context in which it will be used and any user requirements that must be met. If there's a code base already implementing the underlying HTML element, then explore all of the ways it is currently used and what features need to be added by going into that code base and seeing what the developers are already trying to do with that component before you start creating it to be reused. Think about a button component. The text displayed on the button may just be text, or it might need to allow for extra markup. So you might need something like a slot. The background and text colors of a button. What sizes does the design system support? Is the shape rounded or is it not rounded? Does it have an icon? What's the position of the icon? All of those things are things you have to think about when you're designing the features. The different states of the button, hover, active, focus, disabled, there's more than that. The button should be accessible to all users with support for keyboard navigation, screen readers, and other assistive technologies. It should handle user clicks and trigger an action. And finally, it should have the option to customize the styles of the button further to design specs. There are many things to take into consideration when developing a component. Once you have defined the component's purpose and the features, you can start designing its API. The API should be easy to use and provide all the necessary functionality without being too complex. All components in the library should also follow the same API conventions to ensure a consistent user experience. It should be flexible enough to accommodate different use cases and customization options to allow for easy extension or modification of the component's behavior and appearance. The API should be clear and easy to understand with appropriate documentation and examples provided, and should take into account accessibility requirements, such as providing options for keyboard navigation and screen reader compatibility, like we just spoke about. Looking back at the features and taking those into consideration for the API, while also maintaining consistency in the component's API, is key to a successful design system. The props of the button component, or properties, are how we define the API and allow a user to customize the button within the design system parameters. The text may be a label prop or a slot if it needs to be more dynamic. The colors, sizes, shape, and icons should map consistently to the design system's button. There should be props for each state in handling any accessibility attributes and click handlers. Then to handle the customizable style, there needs to be a convention used between all the components. Maintaining that API consistency between components is important to ensure that the design system is cohesive and it's easy to use for the designers and the developers. If you're jumping from component to component, you don't want to be having to search and see what the differences are between the API. You want that API to be consistent. Let's look at the example spelt button component. This is a lot to take in, and I know it's too small, so I apologize. I'm going to zoom in a second. But the component itself will be complex at the sake of the API being simple and consistent. So that's what I meant by flip your thinking. You have to think as the end user developer when they're going to be using it. So this side of the component is going to be really complicated. If we think about all the API considerations, each one is taken care of in this component. If we zoom in, and I know it may still not even be big enough because it's still a lot of stuff. If we zoom into the button attributes, we can see Spelt's class directive. That's the class colon being used to selectively apply those classes only when specific props resolve to true. So we have the class colon, the class name equal to, and then you have in curly braces your actual JavaScript there. And so you have a prop variant. If that is equal to default, it's going to give it the default class. And so on and so forth, all the way down the class list. We're also passing through the disabled prop and the click handler to handle some of those accessibility and state functions. And then on the last line, we see a strange syntax, a little scary syntax. But everyone who knows Spelt knows that they're in love with a $sign. So ... or spread, $sign rest props. And essentially what we're doing with that is spreading the object with the rest of the properties. Anything that we forgot in our API or that the developers need to add on their end that we don't know about can be added through this property in Spelt. It's a special to Spelt syntax, and it contains only the properties which are not declared with the export keyword in a component script tag. In Spelt, you declare a prop by saying export let the name of the prop. So that without that export keyword, this allows the rest of the properties to spread onto the component. It can be used to pass down other unknown attributes to an element in a component. Going down to the code inside of the button, we can see an if block, this is Spelt's special syntax. Some people love it, some people hate it. So we have if icon and the icon position equal to before, we're going to put an icon in. And then we have a span tag with the slot in the middle. So instead of a label, we have a slot because we need to allow for some extra markup. And then we have another if block at the end saying if the icon and the icon position is after, we're going to put an icon at the end. A slot in Spelt is the place where any children of the component go. You say that's where you put your children in their place. And this allows a user more options than just the text markup for the contents of the button. And here are a few of the different ways the button component can be used by the consumer. So now I flip to the other side and actually use the component. We have extra classes being added with a regular class prop. Due to that REST prop syntax, we can just use class. It's not class name or anything like React. And then the icons can be defined with their name, position, and size in an object. And special buttons can be easily declared, and the click handlers are passing through to the button element correctly. The component implementation may look extremely complex, but it's all extracted away, that complexity, for the end user. Creating components for developers to easily drop in and use with a consistent API is vital to a successful design system. The API of a component in a design system is a crucial aspect that determines its usability and flexibility. A well-designed API should be simple, consistent, and easy to use, allowing developers to build interfaces quickly and efficiently. It should also be designed with reusability in mind so that components can be easily adapted to different use cases and scenarios. Finally, it's important to consider the needs of both developers and designers when designing an API, as both groups will be using the components in different ways. With a carefully crafted API, a design system can empower teams to work more efficiently and produce high-quality interfaces that align with the organization's brand and values. Storybook, or another similar tool, is another essential tool in a design system. Storybook is a UI development environment that allows designers and developers to build, test, and document components in isolation. By using Storybook, you can showcase how different components interact with each other and how they behave under different conditions. This makes it easier for designers and developers to see how the different pieces of the design system fit together. Storybook can be used to generate documentation automatically, reducing the amount of manual documentation that needs to be done. I have Storybook installed inside my component library so that it can be used alongside the development of the components, but it can also be used in other projects if I wanted to pull in the published components versions. As you may have noticed, if you can see that little code sample there, there's a few limitations when using Storybook with Svelte. I almost said Storyblock. We have that problem all the time.
Storybook.
The output code for components doesn't render correctly and slots aren't supported. So this has like proxy render context instead of button there because it doesn't read the Svelte code correctly. I'm using the Svelte component story format to write my stories at this point. However, their team has been working hard on adding features and becoming fully compatible, so maybe sometime soon I can actually use their auto-generated documentation. But you still want to make sure that you're handwriting some manual documentation in there to make sure that it's clear for everyone using it. Since Storybook's auto documentation isn't quite there yet, I'm building a site from scratch with SvelteKit. That's one thing they never say as a developer, like don't build it from scratch. But when you're using cutting edge technology, sometimes you have to build it from scratch, unfortunately. So the new site will house documentation for everyone that uses the design system, designers and developers, and provide everything they need to get started using Viz. We're starting the progression off of the current site, which was on Eleventy, as components are created by redirecting visitors from the component page in that old site to this new site. And this is the homepage design of the new site. We are in the very early stages of that, so it is not actually a live site yet. These are Figma representations, but the new component pages that they're going to be redirected to will provide detailed examples, props, usage, design assets, and accessibility documentation. We're in the early stages of migrating off of that old site, so as the components get published, they're going to be redirected to this page of the design system for their own component. And eventually, we will have enough components moved over that I can just move the documentation site and move our domain over to the new site. Now that the cake is all baked, it's time to taste it to make sure it's ready to sell. Just like a baker tastes their cake to ensure it's up to the standards they have set, testing is an essential step in the development process of any software project, including a design system. Testing helps to catch any bugs or issues with the components before they're used in production. There's many testing libraries that can be used, and pretty much all of them work with Svelte, some better than others. The Svelte team recommends using VTest and Playwright for testing. You can add those right in the CLI when you're creating your SvelteKit application. And at Provi, the main application uses Jest, which is another thing we won't talk about today because it's painful. We wanted to be able to align the design system and potentially reuse some of the tests already written. There's definitely some limitations when using an ES module application like SvelteKit and that uses Vite under the hood with a library that doesn't have first-class support for them. Jest does not have first-class support for ES modules. It's still in experimental state. I ran into an issue when I was packaging my component library with Jest, adding it into the main application. It didn't recognize the default exports in the main index.js file. These 2 lines in the package.json ended up making Jest happy on the other end. But because I wasn't publishing the spelt fields, the src lib index.js file, it broke the Vite build in the main app. So Jest and Vite Webpack and Vite trying to be happy together were not working, and I ended up having to publish both the uncompiled versions of my Svelte components along with the packaged version that is in the dist directory that you see in the main. And so until there's a fix, which we think it might be Svelte Jester package, which is something that Jest uses under the hood to compile a Svelte component. So hopefully someone else smarter than me will get on that and fix that. It's not ideal, but it works for the time being. Playwright is something that I've been looking at adding in the future for its powerful end-to-end testing that runs in real browsers with cross-browser support testing. It's built with speed in mind, a robust API, DevTool integration, and supports multi-page application testing between pages and frames, and it has first-class support for ES modules. Above all, choosing a testing library that works best for you and your design system is key. A component needs to be tested to ensure it is functional and ready for use, just as a cake needs to be tasted to ensure it's delicious and ready for sale. With proper testing, users can have a positive experience with the component and trust that it will work reliably. Now that our cake has been baked and tested, it's time to package it up and get it ready for sale. In the software development world, packaging is the last step before the library is ready to put on the shelf and be made available for others to use it in their projects. Svelte makes creating those libraries that will be packaged and published fairly straightforward. In the last section, we used the SvelteKit CLI to generate the library project and create the components, and now we can use the Svelte package command to generate a package of all the components. There's a package script with the generated library project that runs Svelte package, along with sync and publint that will take the contents of the src lib folder and generate a dist directory with that. All the Svelte components will be pre-processed and TypeScript files are transpiled to JavaScript. Type definitions are generated for you if TypeScript over version 4 is installed, and it can be ran with pnpm package or whichever package manager you end up choosing, and setup is configurable by editing the root package.json file. The exports key in a library's package.json file indicates that the library is using ECMAScript modules, or ESM format, for exporting its code. The dot indicates the current directory, which means that the main entry point for the package library is located in the root directory of the package. All files in the src lib directory will be packaged and then put into that root dist directory. This can be customized to any directory you wish, and other folders can be declared as well to be included in the package files seen here with the styles. Running the Svelte package command will package up your lib directory and take care of all the pathing and typing for you. Now that the components have been baked, tasted, and packaged, it's time to publish them up and sell them to the world. Publishing a component library is an important step in the development process, as it enables other developers to use and build upon the components you've created. It can also help to establish your organization or brand as a thought leader in the space. To make a component library available to others, you'll need to publish it to a registry like the NPM registry, where it can be discovered and installed by other developers. So I lied a little bit when I said you'll never have to run NPM again, because you will. First, you'll need to have an account on NPM, and once that's created, you can run NPM login from any terminal or set up your account on your device. After you successfully logged in, you're ready to start publishing packages, and you can publish under your own name or an organization that you are added to on NPM. The name of the package is taken from the name field in the package.json file. Here at GetProvi is the organization, and Fizz Components is the package name. Now that all of the setup is finished to publish the package, you change into the directory you want to publish and run npm publish and add -- access public if you want it open to everyone. Since I work in a mono repo, I have a root script set up that will change the directories for me and run the command. If you have 2FA enabled, and you should, then you will have to enter the authentication code. And as long as there's no other issues or errors in your bundle, then you will you will successfully publish to the NPM registry, and your component library will be accessible to the public. Publishing a package to NPM is just the beginning of actually selling a package. Once the package is live, it's important to gather feedback from the community and make improvements based on that feedback. This can involve updating documentation, fixing bugs, and adding new features. The feedback loop is crucial to ensuring the success of a package as it helps to build a community of users and contributors who can help improve the package over time. Contributions from the community can also help improve the package and make it more valuable to users. Encouraging those contributions from developers can lead to a more diverse set of features and functionality, as well as improvements to the quality of the code base. By welcoming contributions and actively engaging with the community, the package can become a valuable resource for developers looking to build high-quality applications. In terms of measuring the success of a design system, it can be helpful to set specific goals and metrics. For example, you might track the number of components in the system, the number of teams using the system, or the time and cost savings achieved through using the system. Additionally, soliciting feedback from teams and users can help you identify areas for improvement and ensure that the system is actually meeting the needs of the organization. Selling the package to stakeholders is also an important aspect of the process. Making a design system open source can lead to increased exposure and recognition for your organization. Additionally, it's important to emphasize the benefits and value it can bring to the organization. Some key points to emphasize when selling a design system to stakeholders are consistent branding, time and cost savings, improved communication and collaboration between teams, allowing them to work together more effectively, and scalability over your organization. Also, it's important to use business terminology instead of development jargon. We get so bogged down in development stuff that we forget that these people aren't developers. We need to use terms such as increased productivity, brand consistency, return on investment or ROI, can help make a compelling case for your design system. As the company expands and launches new products, the design system can ensure that they are consistent and high quality. So who owns the design system? The ownership of a design system can vary depending on the organization and how it's structured. In some cases, a dedicated team or individual may be responsible for creating and maintaining the design system. In other cases, ownership may be distributed among various teams and departments. Regardless of who builds it, though, the design system, it's important to have a clear understanding of its purpose, goals, and scope. This can help ensure that it's aligned with the organization's overall strategy and that it meets the needs of all of the stakeholders. Ownership of a design system should come with a sense of responsibility for maintaining and evolving it over time. This includes keeping it up to date with the latest design trends and technologies, addressing feedback and issues, and continually improving its usability and functionality. Ultimately, the success of a design system depends on dedication and collaboration of everyone involved in its creation and use. It belongs to everyone. Building and selling a design system is a complex process that requires careful planning and execution. Each step along the way builds a solid foundation to continually create a consistent experience. You need the right recipe, which includes identifying those key ingredients such as typography, color palettes, and tools to get started. The baking process that involves using those tools to build the components, test them thoroughly, and package them up to sell to the world. At the end of the day, a successful design system is one that is owned by everyone and used by many. By following the recipe, baking the components, tasting the cake, and selling it to stakeholders, you can create a design system that not only meets the needs of your organization, but also contributes to the broader design community. Let's get baking. Thank you.